Hey everyone, good morning. My name is Yaarit, and I'm the tech lead for Telemetry. So today we're going to talk about Ceph Telemetry. We're going to see an overview of the project. We'll talk about the motivation for Telemetry, about the architecture. We'll see some demo for the dashboards, and we'll talk about some success stories that we have. So wouldn't it be nice if we could tell how many Ceph clusters are out there in the wild, what versions they're running, what's the storage capacity distribution that they have, what drive models Ceph clusters are running out there, and which crashes their experience, and so much more. So this is why we have the telemetry module, where clusters can phone home. Yeah, we're good. Oh, it's better this way?
Yep.
Can you hear me? Okay. So clusters can phone home to report anonymized and non-identifying data about their installations and configuration. And then we aggregate the data at the backend and we present it in public dashboards at telemetry-public.ceph.com. It's important to say that the phone home capabilities are built into Ceph, and the default home is upstream at telemetry-ceph.com, but clusters can be configured to phone elsewhere as well. So we first introduced telemetry in Mimic in 2019, and ever since we see a steady opt-in increased trend from the community. We have about 2,500 clusters reporting with nearly 1 exabyte total storage capacity. We're this close to cross the threshold, with about 130K OSDs reporting. It's important to emphasize that by default, telemetry reporting is off, and users need to strictly opt in to the service by agreeing to a license. They can either do it with a CLI command with Ceph Telemetry on, or by using the Ceph dashboard wizard. And they can preview a report with Ceph Telemetry show all or preview all since Quincy, and before that with Ceph Telemetry show. So the telemetry report is compiled from several channels. It is compiled daily, and once the user is opted in, they can turn channels off or on. So currently we have 5 channels. We have the basic channel, which reports Ceph and kernel versions, basic information like cluster size, number of daemons, and so on. And then we have the crash channel, which has a backtrace of crashes, like metadata of crashes that happened in the cluster. We have the device channel that reports health metrics of the drives in the cluster, mostly smart metrics, and some NVMe metrics were applicable. There's also an ident channel, which is off by default, which allows user to add some contact details about themselves, like email and organization. And in Quincy, we added the perf channel, which reports various performance counters from the cluster. So the basic crash and device channels are on by default, and the ident and perf need to explicitly opt into them, to turn them on. We take privacy seriously, and whenever we add data to the telemetry report, we require users to re-opt in. Otherwise, since Quincy, they can keep sending the data that they already opted into. The reports do not contain any sensitive or identifying data like pool names or host names and object names or contents. And the way that we identify the clusters is by assigning them a random UUID, so we can have time series data at the back end. But the FSID of the cluster is never reported, and we redact any serial IDs of the drives, and we never ever store IPs. And we also have separate telemetry reports, one with the anonymized cluster data and the other with the drive health metrics, and they're sent to different endpoints. So why do we need all that? developers want to get some feedback about the features that are used in the wild. Generally, if we launch a new feature, we want to see how it is adopted by the community. And we also learn about the version adoption rate. Once we release a new version, we want to see how it is available out there. We also learn about the hard disk and flash drives model that users are deploying out. And we have a long-term goal to create an open data set of drive health metrics, which allows for research on drive failure prediction models. There are very, very few resources out there that have time series data for drive health metrics that can help the community to come up with better drive failure models. And this is one of the things that we do with drive health channel. We also learn about new bugs and issues as soon as possible by processing the crash data that we'll talk about right away. And it helps us to prioritize issues and to focus on the most common bugs. You can see crash trends through versions. And we can verify that the solution works, because once we provide a fix for a bug, we can see that we can verify that it does not appear in the same clusters that upgraded. And we can also identify regressions. And for users, it's very helpful for them to validate their own installations by looking at what is common. Their contribution to the open data set of the drive health metrics is a win-win, because once we have better failure prediction models, it allows for preemptively mitigating the failing drives and reducing downtime and moving it to a maintenance window. And with a crash channel, users do not need to actively report issues or open tickets anymore. So once a crash happened in the cluster, everything is automatic. Everything is being reported to our backend, and we sync it with our bug tracking system. Users can also use the open data set of crashes that we have in our bug tracking system to better understand an issue. So for example, if they recognize an issue in their own cluster, they can search tracker and see whether there's a fix and what version the fix is in. So let's talk about the architecture. On the left side, we can see a Ceph cluster, and the manager daemon once a day compiles a couple of reports, once for the cluster data and the other for the drive health data. And it sends it to our backend at Telemetry Ceph.com, where we have an Apache server and a Postgres database that does all the database backend for our telemetry. And we have a couple of Grafana instances, one for the public dashboard and the other for a private dashboard. And like I mentioned, the data collection mechanism is built into Ceph, so there are no additional tools needed for that. Let's take a look at some numbers. So this is our, okay, that's not full screen. I can. Okay, that's better. Can you see it well? Is it big enough? Okay. So we can see that we're getting very close to that 1 exabyte of total storage capacity reported by the community. And we can see here the version by cluster count. We can see that currently in the wild, the most common version out there is Quincy. We can learn about the adoption rate if we want to see just the breakdown by versions for Quincy, for example. So we can pick displaying by minors and just Quincy, and the dashboard maybe it's better this way. Yeah, so we just released 17 to 6, and we can see that already 113 clusters are reporting it in telemetry. And we can also see a breakdown by storage capacity. So, for example, this one is specifically for Quincy, but if we change it to breakdown by all versions, by major versions, we can see how big the clusters, that the total capacity by version for all of them over time. So here we can see that there's most of the larger amount comes from Pacific. Sorry. Yeah, it's stable release out there. We can also see the distribution by. Sorry, this is quite a big query, and many people ask about how to read that. So we can go over it real quickly. This is a histogram, heat map that is like time series histogram. So we can see that, and it shows the cluster distribution by total storage capacity. So we can see that most clusters that report are about 64 to 128 terabytes. And there are some big clusters that report about 6 clusters that are between 16 to 32 petabytes. So these are some. Are we out of full screen? Yeah, okay. I had some screenshots here because I wasn't sure if we're going to have the chance to look at the dashboard itself. I wanted to go over some graphs on the Drive dashboard as well. I think I have it here. So we can see breakdown by vendors on the public Drive dashboard. We can see that it's Seagate that has the most drives out there in the reporting clusters. And we can take a look at the drives by types. So it's mostly hard disks that report, and there are some SSDs and NVMEs that report as well, but mostly hard disks. And for interfaces, we can see that among SSDs, there are a lot of SATA drives reporting, and for hard disks, it's also mostly SATA. And if we want to see some more detailed views, so for example, if we're curious about the breakdown of Seagate drives, we can see that there are mostly, again, hard disks of Seagate, and we can see like a more detailed view of the types of drives that report. All right. Now let's talk about the crashes. So the crash report contains the crash ID of that's reported in the cluster itself, the daemon type and name, the Ceph version, the backtrace, some information about the OS, the kernel version. We have an assert message and condition and function, if applicable. And if the user opted in to the basic channel as well, we can have some more detailed view of like basic configuration of the cluster, and we can have some more deep dives to find more relations between crashes and sizes of clusters and so on. And we have many raw crash reports, and we need to process them in a way. So if we take a look at these couple of raw backtraces, from a developer point of view, they represent the same issue, but they're not identical. So the differences are due to different Ceph versions or different compiler versions or compiler optimizations that change the symbols, the addresses, and the offsets. And the way that we make them similar is by removing these offsets and addresses from the backtrace frames. We use regex to search and replace some patterns that make the frame look similar, and we also filter out certain frames at all from the backtrace. So now we have a way to group similar raw crashes into a signature or a footprint of a crash. And this is, and we also allow for backward compatibility for for improved recipes of crash signatures. So for example, if now we find additional patterns to filter out the backtrace or search and replace, we can apply that recipe on the back end and then have the recipes, the older signatures mapped to the new one as well. So this is also not enough to have a group of signatures in the database. We need to take some action. So this is where the telemetry bot is doing its work. It queries the database for the most recent crash signatures, and then it maps the crash signatures into Redmine issues. And the way it does that, it searches Redmine for all of these signatures that are related. So either for backward compatibility, or sometimes users open bugs on their own, and they have their the crash signature that is currently available in the cluster, which is not always similar to what we have up in the backend. So we know exactly how to map them. If we find a ticket, then we update it. Otherwise, we open a new one. And we add all of the essential information, like the affected versions. We give an example of a raw backtrace and like the sanitized backtrace for developers to understand exactly how it's grouped. And we have a link to the dynamic dashboard to take an in-depth look. The bot also knows how to identify regressions. So for example, if we, let's say that we open an issue and it's fixed, and now we receive new reports in telemetry for the exact same signature, but with a newer version, then the bot knows to identify it and open a new issue and say, hey, it looks like this ticket was fixed, but we receive new crashes with a newer version. Please take a look. So the dashboard allows for searching by backtrace frames. We can see crashes by versions, either major or minor. We can search by signatures, by a search function and conditions, and so on. And we can also have the drill downs to see some in-depth cluster information, yeah, and we can see the trends through versions. So we can see daily occurrences and so on. Let's just see that instead. So for example, here, I don't know if it's big enough. So here is the dashboard that we have specifically for the crashes. Here we have a few input fields that we can search specifically by frames. We can look at crashes that happened in a certain version. For example, if you want to take a look at Pacific versions or versions, crashes that happen in Quincy. And we can also filter by daemons, assert messages, and so on. So, for example, here we can take a look at this crash. So you can see that when it was first and last reported, we can see how many crashes were reported through telemetry, how many clusters were affected by that. We can see the breakdown by version, and also this one we have information about the assert message and condition. We have a daily occurrences of the reports that are related to this specific signature. And here we can see the affected clusters. We can see the size of them, total unused capacity, and all the breakdown of the details of these clusters. And we can also have a deeper dive in for each cluster. And we can take a look at individual crashes. So for example, if you want to see a raw crash, we have everything here in the dashboard. Sometimes users choose to identify themselves, so we will have contact details here, and sometimes we do need to contact users and ask for additional information if they have it. Another cool thing that we have is, for example, if we want to search, let's say that we're curious to see all other crashes that have this frame in them. So we just click on the sanitized frame, and we see all of the fingerprints of the crashes that have this specific frame in them. And then we can keep on filter out crashes by the additional fields for the frames. And here we can see that yeah, this one is not updated, but we have the link for the tracker that the bot updated. So this one specifically was opened by QA. The bot found that ticket, and it updated it with the relevant fields and a link to the dashboard. Please feel free to stop me if you have any questions. Okay, so we do have a crash triage and queue custom queries per project in Redmine. Now it's important to mention that there are a lot of crashes, but they're not all Ceph bugs. So sometimes we can take a look at the dashboard and be horrified that there are many crashes. It could be hardware issues, errors, and so on. It can also be configuration issues or any environment problems that have nothing to do with Ceph, or just issues with other dependencies that we receive these crash reports for. So we can monitor the crash reports of new releases. And one of the exciting things that we've seen with the telemetry so far is bug fixes to crashes that happened in the wild. So for example, here, the bot opened a ticket for a crash that came from telemetry, and we can see that we have the breakdown by versions, and we have some details here for exactly how the, like we have an example for a raw crash dump, and how we decided to filter this backtrace too. And you can see that this was picked up by Ceph's developers, and they fixed the issue. So there's a pull request here for a crash that was reported automatically by the community and synced automatically with our backtracking system. And tech leads review this in their bug scrub, and sorry, and they see how common issues are, and it gives them more idea of how important an issue is, and it really helps with prioritizing. I know Adam is going to talk about it a little later. This one is another example for a crash that also had a fix, and it needed to be backported 3 versions back. So it shows you how important that is to communicate with developers, because sometimes an issue can go further back and we just don't know it. And there's an example here for that. This bug was opened by a user, and their cluster was running version 17, but when we looked at the dashboard, Nea and Radik looked at the dashboard and they noticed that it actually happened as early as 16.2.5. So we know that we have some more data points to understand that it's not just a Quincy bug. We see reports for the exact same issue as early as 16.2.5. And the way that they could do that, they were searching by, I believe, the assert message here. So they could just enter the assert condition, and they saw all of the other crashes that happened. And some of them are from Pacific and some from Quincy. This example I find exciting in particular because this issue was opened by the Telemetry bot. And the fix itself came from the community. So someone in the community experienced an issue in their cluster. They searched Tracker. They saw that issue that was opened by the bot, and they just provided a fix for that in BlueStore. So that helps in increasing the observability of issues that we're facing or other users are facing. And so the fix itself can also come from the community. And there are some more examples that I wanted to show that are not necessarily for crashes. So for example, when we wanted to deprecate file store, we wanted to understand how common file store is among users. So we ask questions in the mailing lists. We have user developers meetings that we bring up these questions. But we can also look at what clusters are reporting. So we can see that basically file store is almost non-existent. So this is a breakdown by major versions, and we can see that there are some Octopus clusters that report that, but for Quincy, everything is BlueStore, and for Pacific before that, there are very, very few daemons that run file store. So this is, generally speaking, a more accurate data point. So if you want your cluster to be heard, and we want to understand whether features are in use or if you want to deprecate them, or to better understand if there are any crashes that are related to these features, telemetry is the best way to do that. And it helped us in understanding also how an Erasure Code plugin is being used, and if there are any related crashes to that, and to help with scaling for the Ceph dashboard by understanding the magnitude of RBD images that are deployed by users out there. So again, we can ask in the mailing lists, but it's not the same as seeing the actual data. Yeah, I think that's mostly all I had. Please consider to opt in with the Ceph Telemetry on, or by using the dashboard wizard. It really helps. So yeah, thank you. If you have any questions, happy to take them. One thing I'll mention, and I briefly mentioned it in the keynote earlier, we do want to have a better way to track the crashes per cluster. So for example, if your cluster is opted in and you are opted into the crash channel, we want to provide a view for users to understand whether their crashes have been synced with Tracker, and if there is any fix for them, or in what version the fix is. So to bring even more observability to the user, either via the public dashboards to have a specific view for that for each user, or like to have a callback option. Go ahead, Radik.
Here I interpret the slide as basically a Ceph cluster found home.
Yeah.
But I wonder whether home would call. Oh, sorry. Okay, I interpret this the slide as basically Ceph cluster calls home. But from practice, from going over to Tracker, doing bug scrubs, I know there are situations where, okay, we've got a perfect bug report when it comes to bug trace. But it's simply not enough. We are switching from new, the status of the automatically created bug. We are switching it from new to needs more info.
Right. And
sometimes, if we are unlucky, if the identity report is unavailable, well, sometimes those bugs are put to the fridge for years. That's bad. On the other hand, it's absolutely out of any question we need to preserve privacy. But I wonder whether we could have both things the same time. We know we store some kind of anonymized cluster ID, and now we are also considering providing some back communication channel from home to a Ceph cluster to convey information that, okay, here is a fix. But could we consider? I wonder whether it will be possible to inform a user that there is a update requiring his interaction, like usually providing extra logs. Maybe we could inform people that a bug that happened on their cluster got into the need more info state. That would be super cool.
Or a possible disk failure.
Okay, that's another, just to the record, another extension, coming disk failure. That would be.
Right, with the drive health metrics from the device channel. Yes, definitely. So these are, there are a couple of avenues that we're thinking about it, either having it in the public dashboards that users can basically go on the public dashboard, their own private page, and see any notifications that are coming from our backend, or to have a callback option that users explicitly enable, so we can phone back and say there's an imminent drive failure, or we need more information about this crash, or this fix was resolved in Quincy, or yes. Are there any users or any feedback from would you opt into that? Yeah. Okay. Okay. Perfect. I'm glad to hear.
So I recently did a lot of deployment tests, and so kind of we opt into telemetry and we're happy with it. And I know for production that's really useful for you, but then on our much smaller dev clusters, we've been rolling out 2 or 3 times a day a new cluster where we're just testing stuff. But I've had telemetry on there because I mean, if a crash happens, it would be great to have it on there. Right. But then sometimes I switch it off because I feel bad because I'm polluting your data set. Is there a flag that we can set that this is a production cluster and this is now like a guy playing?
So you can identify the cluster as a Ceph QA cluster, and then we know that. So with the ident channel, we describe it as a Ceph QA, Ceph-QA. So this way we know we can filter it out and we can use the information like crashes. Yeah. Thanks. That's a good point. I should include it.
Yaarit, is that case sensitive?
Yes, but we can make it. We can make it case insensitive. Currently, it is. Yes.
It's all like lowercase Ceph-QA.
Yes. Yes. Thanks.
I would like to know how you. So you say that new performance metrics will be added in Quincy. How they will be exploited? They will be used for getting something like an indicator for the performance of a cluster. How do you think to share this type of information?
So there are a few questions that we want to answer with the performance data that we have. There are some memory issues that we want to get a better understanding. We will have some internal analysis, but the interesting aggregated answers to these questions will be available in public dashboards as well. So there are some issues in Tracker that basically we can understand like how many clusters that report telemetry with a perf information experience the same thing. So we know how common that is in the wild. So and by the way, if you have specific ideas, please feel free to ask for these panels. So or we were talking about the idea of having a periodic newsletter that gives some updates. So if there's any interesting information that you would like to see with telemetry, please let us know.
I think it's so if I don't know if the module could be or it's if it is possible to add additional information to the telemetry modules, because I think that getting better visibility is good things for everyone. So also getting the possibility to extend the performance, the metrics monitored could be an interesting opportunity for contributing to Ceph.
Yes, so we do add collections, and in Quincy we added the mechanism to add new collections, but not to opt out the user until they opt into everything, because we changed the data model. So users can keep sending whatever they're opted into, and if they re-opt in, they can add the new collections as well. So we do add new collections with every release. Yeah, if you have any ideas or requests or anything that you think would be useful, so please let us know.
Is there any indication in the telemetry set what method deploy the Ceph cluster? For example, Rook or OpenStack Director or Ceph ADM or something else?
Yeah, so we added some Rook metrics, and they're being processed in the backend. We should have a dashboard soon. Yeah, so there's also orchestrator information as well. So this is work in progress. So yes.
Thank you.
Yeah, thanks.
I have a comment about comment/question on the performance things related to telemetry, to the collection of performance metrics. I'm not sure whether we are collecting this this particular one already or not, but it might be a very interesting use case. In Quincy, I think it was backported to all the releases as well. We introduced a metric for size of the DUPS list of pglog. I'm not sure whether we are collecting it, but it's related to a pretty severe issue that is basically a ticking time bomb, memory leak. So if we have such a thing in telemetry, we could judge how proliferated their issue really is in the wild. At the moment, this is a thing we are perfectly unaware about. So how flexible is adding new metrics, let's say from the PG query thing to telemetry?
It's super flexible. Yes, and we already collect a lot of these metrics. This is specifically, I don't know for a fact to tell you if we collect it or not.
But we can.
Yes, it's
perfect.
It's super easy. There's again infrastructure added to add new collections without breaking the stream of reports. So yeah.
Another thing, if I may, a feedback from a developer. For a long time, I was unaware we have so cute, so super cool feature like telemetry. Really, I was unaware about that. How about bringing a link to it, to the tracker, to the main upper tab of the tracker? Because the ecosystem is growing, and almost nobody knows everything.
Right.
Every single part of the project. People are completely unaware. I know, for instance, I haven't seen also a dashboard for many years on my eyes. I wasn't aware we have things like that. So maybe we should link our tools somehow. Tracker seems the tracker linkage with telemetry with the telemetry panels seems pretty natural.
Yeah. Yeah, that's a good idea. So with the tickets that the bot open, we do have a link for the specific crash signature page at the back end. But yeah, I completely agree that we should add some more visibility for the dashboard.
People learn by
Yes.
exploring. If you put
Yes.
a link on the top of page, what's that? Let's see. Let's click.
Yeah.
Interesting.
Yeah, that's a great idea. We should add it. Thanks, Radek. Any more questions? Going once. Yeah, well, thank you very much, everyone.